should be a good experience. You have 18 minutes to do multiple choice. You have 12 minutes to do the free response.
Well, are you sure this is a good idea?
What?
Are you sure this is a good idea to show the quiz?
That's okay, because no one can see anything, right? It's all good. Thank you for that, Stephen. I appreciate that. All right, everybody's good at the quiz?
Yeah.
Quiz is due Monday. Good. All right. Other thing that you guys have this weekend to do is more of a reading assignment. Next week, when I see you guys again on Monday, we're going to talk about derivatives of inverse functions. This is going to open the door for us to the arcsine function, the arccosine, and the arctangent. We're going to open that door wide. I have never before in my life actually taught a full lesson this early in the year on derivative of arcsine, arccosine, and arctangent, so I'm really excited about doing this. It's only going to go well, though, if you spend some time this weekend reading the stuff that's in here and it says everything you need to know about inverse functions. There's no actual problems for you to do. Oh, wait, I lied. There are some problems towards the end for you to do. There's nothing calculus in here. This is inverse stuff that you remember from Algebra 1, Algebra 2, pre-calculus. And because the 11 of you probably don't remember a whole lot about inverse functions from Algebra 1, Algebra 2, and pre-calc, let me say everything that you do need to know has been summarized here. I am not going to spend even one moment talking about this on Monday. I'm going to assume you did your due diligence this weekend and have like filled in all the gaps, filled in all the holes. Everybody good? 30 minutes on the quiz, probably about 30 minutes here. Probably about 30 minutes here. I wouldn't spend much more than 30 minutes. Did you get the job? Did you get the job? Okay. All right, so let's look at the homework, shall we? All right, homework. So homework last night was, there was like a table of values and all sorts of derivatives, and then some just really nasty derivatives that you had to find. Okay. All right, here we go. I'll just put my solutions up here. Right, first one they asked you for the equation of the tangent line, was that right? Okay, L of x equals negative 2 parentheses x minus 4 plus 3. Aaron, what's up? Okay. Okay, you'll figure it out and you'll catch up with the rest of us. All right, number 2, if a of x equals h of x plus 3 times g of x, then a prime of x is equal to h prime of x plus 3 times g prime. And then you plug in negative 3 using the values from the table, you get 9. Everybody okay with 9? Yeah. Okay. All right, number 3, p of x equals g of x times h of x. So I'm going to take the derivative here. Product rule. Has to be product rule. P prime equals g prime times h plus g times h prime. When you pick all the values from the table, your answer is 14. Number 4, q of x equals e to the negative x over h of x. So a unique quotient rule. A little low, d high, minus high, d low, low, low. H of x times negative e to the negative x minus e to the negative x times h prime over h of x, the whole thing squared. When you pick the values and you plug them all in, your final best answer is negative e cubed over 4. I'll take negative 4e cubed over 16. That's fine with me too. Number 5, your derivative is e to the power of h of x squared times h prime of x squared times 2x. This is one of those extended chain rule problems. Final answer should be 16e to the negative 1 power. Is everybody doing okay? When you guys get this quiet, usually bad things are happening. Everybody's doing all right? Okay, good. All right, number 6, 7, and 8. I'm just going to tell you what the answers are. Number 6, the answer should be lower. Pi times e. Number 7, yeah.
Pi times e?
Okay, pi times e. Number 7, if s of x is natural log of g of x, your derivative 1 over g of x times g prime. Plug everything in, you're going to get negative 3 over 7. Number 8, t of x equals h of natural log of g of x. So this is going to be an extended chain rule kind of problem. H prime of natural log of g of x times 1 over g of x times g prime. You're going to get square root of 2 times e. Good. All right. Derivative number 1, your final answer, cosine of x minus sine of x plus e to the x plus e to the x squared times 2x is your first derivative.
Oh, I was like, oh.
That's the first derivative. Take another derivative, negative sine of x minus cosine of x plus e to the x, and now product rule this sucker over here, e to the x squared times 2x plus e to the x squared times 2. Good. Number 2 derivative is going to be negative sine of e to the x times e to the x minus sine of x to the e times x to the e minus 1. Whew. Plus cosine of cosine e to the x times negative sine of e to the x times e to the x. Plug in 0, negative sine of 1 minus sine of 1 times cosine of 1. Don't ask me what the cosine of 1 is. I don't know. I don't get paid that much to know that. But I do know that my calculator knows what that derivative is. All right. Number 3, your derivative needs to go lower. 2x times sine of e to the x plus x squared times cosine of e to the x times e to the x. Everybody good on that one? Okay. Number 4, your derivative is 2x sine of x squared plus x squared times cosine of x squared times 2x. Now all you need to do is plug in the square root of pi. Notice every time I'm doing one of these evaluate the derivative, you first find the derivative, then you plug in all the stuff. Your final answer would be negative 2 pi times the square root of pi. Okay. All right, number 5, sine squared of x squared. This was that nasty one we were talking about yesterday. Sine squared means sine of the angle, whole thing squared. So now it's clearly a chain rule with a chain rule inside. Plug in, you're going to get 0. Number 6, hopefully not too bad, little quotient rule going on. Your answer, x squared times cosine of e to the x times e to the x minus sine of e to the x times 2x over x squared squared. When you plug in e cosine of e minus 2 sine e. All right, we're almost there. Number 7, natural log of the cube root of sine of x squared. Gosh, it would be so much better if you used your log properties first. Natural log of the cube root of stuff is the same as 1/3 natural log sine of stuff. And then your derivative 1/3 times 1 over stuff times derivative of stuff. Love this answer. Did anybody rewrite 1 over sine of x squared times cosine of x squared as cotan? Carmen did it as cotan. Everybody else left it 1 over sine times cosine? Perfectly fine. Perfectly fine. And number 8, just a nasty chain rule problem that also involves a quotient rule. And look what I did, even at like 40 some odd years old. I said, I got stuff squared, 2 times stuff to the first, times derivative of stuff, but I wasn't ready to use the quotient rule yet. And now I start using the quotient rule and I plug everything in and it comes out to be 2 pi. Yep.
You know the number 7 has 2? I want to see the last part of that. Oh, 2x.
Everybody aye? All right, so if you could put that in the middle of the table, please, paper picker up, or if you could pick up the papers, please. There we go. For those of you that had some corrections that you were going to do, and there was a note on it that said, corrections by Thursday. Today's Thursday. So if you have those corrections, if you want to put those in the middle of the table as well, that would be great. All right, let's do a quick little check on our derivative skills because there's going to be an opportunity for lots and lots of stickers to be earned later. All right, product rule. Everybody, what's product rule? What does product rule say? Yeah, everybody.
Oh, the derivative of the first
Derivative of the first
times the second
times the second
plus the first
plus the first
times the derivative
times the derivative of the second. Quotient rule. Polymon.
Loading minus the high low.
Okay, and for all the folks on this side that couldn't hear it, low D high and then minus high D low, low, low. All right, chain rule. Andrew, what's the chain rule?
F prime of G of X
F prime of G of X
times G prime of X.
times G prime of X. Love it. Derivative of 1 over X. Who's got it for me? Celeste.
negative 1 over x squared.
Negative 1 over X squared. Derivative square root of X. Who's got it for me? David. 1 over 2 square roots of X. Derivative cubed root of X. Cubed root of X. Cubed root of X. Stephen.
1 over 3 times cube root of X squared.
Right, so it would be 1, and then in the denominator, 3 cubed root of X squared. Nice. Derivative sine of X. Aaron. Cosine of X. Eileen, derivative of cosine of X. Negative sine of X. Derivative of e to the X. Lewis. And the derivative of e to the negative X. The derivative of e to the X, e to the X. Derivative of e to the negative X, think chain rule.
So e to the x times negative 1.
E to the negative X, right? The power stays the same, times negative 1. Derivative of natural log of X. Natural log of X. Myra. 1 over X. Well done. Derivative of tangent of X. For 2 lifesavers. Derivative tangent of X. Carmen. Okay, hold on. What I heard you say first was secant of X squared, and what I heard you say second is secant squared of X. Which one? They're not the same?
No.
Right, because in this case, this means secant of X squared? No, ma'am. All right, you get 2 because you make beautiful posters. And we're going to talk about more beautiful posters coming my way. All right, one more that I really want to make sure that you know. It's going to be a time saver. Is the derivative of secant of X. Now, if you have your foldable, you have it. David, what was it one more time?
Secant of X times tangent of X.
It's secant of X times tangent of X. Correct. Secant of X times tangent of X. If you didn't know that, then I would rewrite secant of X as 1 over cosine, do a little quotient rule action, and this would work just fine. And all the friends are okay? Lewis, just absorb it into your big brain. It's gonna be all right. All right. So here's the thing. I want to do one proof. I want to spend no more than 8 minutes on this because I want you guys to have the rest of the period for some practice time. We're going to prove that the derivative of sine of X is cosine of X. And this is the kind of proof that's going to hold up in mathematical court. Judge Judy would count this as a proof. I am in the handout. I'm on page 25. I know that everybody in the room and everyone on the other side of the camera knows that the derivative of sine of X is cosine of X. When we did it, we looked at the graph, we sketched the derivative, we checked it on the calculator, and everyone was like, I got it. Not a proof. A proof involves definitions. A proof involves formulas. A proof is something more significant. And one of the things that we learned way back in the day, there was a formula for finding a derivative. There was a formula that involved limits. We're going back to limits.
Are you serious?
Yes, that is what a proof would involve. A proof would involve going back to our definition of the derivative. There are 3 different definitions for the derivative, 3 different formulas. I want the one that works for like a function. I'll give you a hint. It starts with limit.
Thank you.
Oh.
1, 2, Aaron, what you got?
H approaches 0.
H approaches 0. Yes!
Oh,
F!
f
Yep.
x plus h. Wait.
F of x plus h
So-
minus f of x all over h.
Yeah, there you go.
I'm so bored. I'm so bored.
Tell you.
Thanks a lot. All right. This is the definition of derivative. This is where Newton started his work. All these things that we know, product rule, quotient rule, chain rule, these are shortcuts. These are results of the work that we've done. Everybody okay? So here's the thing. What I want to do is I want to find the derivative of the sine of x. So let's do it the right way. The sine of x is your function. This is f of x. So if I'm going to apply this rule, the rule says take the limit as h approaches 0, f, plug in x plus h, is the sine of x plus h minus the sine of x all over h. If you were to see this on a test, on a quiz, on the AP exam, in a dark alley some night, if you came across and said, gosh, limit as h approaches 0, sine of x plus h minus sine of x all over h, what am I really asking you for? The derivative of sine of x. You guys know what the answer is.
Cosine.
Cosine of x. One of the dirty things that the College Board likes to do, they'll just put this on a test and be like, hey, what is this? And people start to panic. But if they saw that all this really is the derivative of sine of x, wouldn't everybody be okay? Okay, but we're going to go for the proof.
All right.
Okay, so let's try this. If I take the limit as h approaches 0, well, what happens here? If I try plugging in,
It'll be over there.
h approaches 0, so I've got sine of x minus the sine of x all over 0. That's the indeterminate form. Uh-oh. Need some trickery. Need some good trickery. And it is trickery that I don't think your pre-calculus knowledge or trig experience is going to help you with, and it's not his fault. It's not, so don't look at him like that. This guy here, there's an identity. There's something called an angle sum identity. And the angle sum identity for sine says the sine of a plus b, the sine of a sum, is equal to the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second one. This is your angle sum identity from trig that most of you, I don't think anybody would have seen.
No, we saw it.
You did? You just don't remember it? Steven and all of your midnight Googling, have you come across this?
No.
No. Sine of a plus b equals sine of a times cosine b plus cosine a times sine of b. So let's use it.
Yeah.
Limit as h approaches 0. Sine of x plus h is going to become sine of x times cosine of h plus cosine of x times the sine of h. I'm just using my angle sum to rewrite this. Minus sine of x all over h. Well, I don't know if that's better, but I know it's legal. What happens if I let h approach 0? Sine of x stays sine of x. Cosine of something getting closer to 0 is 1. Plus cosine of x times sine of something getting close to 0, 0, minus sine of x. We had sine of x times 1 plus 0 minus sine of x. Guess what? The whole thing's still 0. Still 0 over 0. Still the indeterminate form. Sucky. Well, let's go a little bit further. And these are not moves that I would expect you guys to come up with on your own. What I'm going to do is I'm going to regroup this a little bit. I'm going to say, how about if I do this? Limit as h approaches 0. This guy has a sine of x. This guy has a sine of x. What if I write those together? sine of x cosine of h minus sine of x. Is that legal? I'm just like moving those around, right? Plus the cosine of x times the sine of h. Now the whole thing's being divided by h, but I'm going to divide this set by h and this set by h. I'm just choosing to write this as two separate fractions. They each have the same denominator. I just care the algebra. Are we okay? Algebraically, this fraction plus this fraction is this fraction up here? Okay, here's the reason I'm going to do this. One of the limit properties that we have is that the limit of a sum is equal to the sum of the limits. So take the limit as h approaches 0 of sine of x times the cosine of h minus the sine of x all over h plus limit as h approaches 0 cosine of x times sine of h all over h. I'm writing the limit of this sum as the sum of the limits. Now, important thing to pay attention to here. H is what's changing. H is what's getting closer to 0. X is not changing. So for this problem, x is a constant, which means sine of x is a constant. This sine of x over here, also a constant. So I could rewrite the numerator if I wanted to as sine of x times cosine of h minus 1. And because h is what's changing, but sine of x is not changing, I'm going to factor this sine of x out in front to say that this is the sine of x times the limit as h approaches 0, cosine of h minus 1 over h, plus I'm going to do the same thing over here. H gets close to 0. X and cosine of x are not changing. They're constant. I'm going to pull that out in front. So that's cosine of x times the limit h approaches 0, sine of h less over h. I know just a whole lot of fancy algebra and calculus has been happening here.
The S and cosine.
The s and cosine, when, yeah, that, there's a little casualty there. Limit as h approaches 0, cosine of h minus 1 over h. Well, let's try this. Limit as h approaches 0, cosine of h? 1 minus 1 over 0. Dang it. Limit as h approaches 0 over here, sine of h over 0. Oh my god, still, why goodbye? Both of these limits here are well-known limits that we've actually studied, we've actually evaluated. At some point back in the day when we were looking at the squeeze theorem, ooh, Carmen's like, oh, why'd you do that on a Thursday, coach? Using the squeeze theorem, we proved what this limit was, and we proved what this limit was. You also could evaluate this limit on your calculator. And so I want you guys to impress me, either with your knowledge of the squeeze theorem or your knowledge of limits on the calculator. Evaluate this limit for me, evaluate this limit for me. If you're using the calculator, it's a little bit of a cheat step right now. The squeeze theorem would be the way to go. But no one remembers the results from the squeeze theorem. So if I'm evaluating this limit on my calculator, plug in this function here, cosine of x minus 1 all over x. Take the limit as your x values are getting closer to 0. Lewis is going back to the Unit 1 packet, looking up these different limits. Carmen and Steven are faking it as well. They're like, let's just flip through some papers.
Lewis, page 24.
Page 24, apparently.
How do you remember that?
He also has access to his computer and a degree from Rice University. And he's vegetarian. Vegetarians are smart, so you know. All right.
Oh, the sine of the limit as h approaches 0, sine of h over h is 1.
The limit as h approaches 0, sine of h over h is equal to 1. I agree. The limit as h approaches 0, cosine of h minus 1 all over h. What do you hope it's equal to?
Something not zero.
All this work was to find the derivative of sine of x,
Cosine.
which we know the answer is
Cosine.
cosine of x.
So
So what do we hope this thing is?
Zero.
0. We hope it's 0. Either you're going to prove this on your calculator, or you're going to find it, or Mr. Link's just going to like call it out at some point. But that limit is 0 as well. This limit here is 0. So if all those things happen, unless I'm lying here, what we get is that the derivative is sine of x times 0, which you guys know is 0, plus cosine of x times 1, and so your final answer is
Cosine.
cosine of x, and all proofs end in a smiley face. That is the legit step-by-step proof that the derivative of sine of x is cosine of x. This is how you would prove it. I do not expect to ever assess you on the knowledge of a proof. So don't freak over this.
No.
This is to know. This is to push your limits. Yeah. For the calculus BC kids, I want you to see this. I want you to like have been exposed to this. For the calculus AB students, this is not the thing that I would be worrying about right now. I would probably skip this entirely. For anybody who happens to be watching the video right now, planning your lessons, I wouldn't do this with the AB kids. All right. What I would do with you all, what I would do with the AB students, is give you guys some time to practice some really tough questions. For the next 15 minutes, your goal is to work, it's pages 27 and 28, oh, and 29. If you really want to push yourself, try question number 1 or number 3. For my physics people, question number 5 is also an excellent question. The rest of this period is just going to be practice time. I'm going to randomly call people up. We're going to put your work underneath the document camera for all the friends to see. I'd focus on 1, 3, and 5. For the friends at North Central and East End, we're just going to be in a lot of work time, so you might want to just turn off the sound, start working on the problems that are on pages 27, 28, and 29. Problems 1, 3, and 5, high priority questions. I would spend some time there. Enjoy the ride. Corrections and such. Thank you all. And Andrew, in a couple of minutes, I'm going to give you an opportunity to earn your power rule paper. Just y'all caught up with the rest of the time.
It was already far.
That's a pretty booty list.
He said, do you want to have first problem? What?
All right, in 1 minute, I am randomly selecting some teenager,
Product rule.
and we're gonna display their work for 1A.
Plus x squared times derivative of x. Derivative of the first term is equal to plus okay.
I thought this was the derivative of the first. Oh my god.
Is anyone planning to do the derivative foldable and maybe you'd like some colored paper?
Can I redo it?
Yeah. Watch the video, it has all the things on there. Alright. And if you're doing the derivative foldable, here are little slips of paper.
You want?
All I get is.
Oh, you did the paper? Oh my
I
god.
was like, oh, okay. Put this in the middle.
You don't have to do the foldable, but I think you're gonna find it helpful.
Oh, well, you didn't raise your hand. I thought my foldable wasn't good enough for you. Yeah, it's all on Google. Why would I need this? Last night there was a meeting in our neighborhood with the new superintendent for HISD, and there was this like Q&A time, and people got up and asked him questions. And this one guy used the word Googling. It sounded like the dirtiest word I had ever
Stop
heard.
talking about it.
He was like, well, I was Googling. I was like, ew. When I was Googling
That was your
you.
fault. You
Like, whoa. Say it that way, someone will go to jail.
Alright, so get some work from a random student, random student for 1A, and this random student, I let you get your hand up back, right? Alright, g of x equals x squared times f of x. She wants g prime of 2, product rule, clearly product rule. So g prime is 2x times f of x plus x squared times f prime of x. How are we feeling about that? Everybody good? I would say that's probably worth 2 points. 2 points. G prime of 2, now you're going to plug 2 in everywhere. 2 times f of 2 plus 2 squared times f prime of 2. F of 2, how on earth am I going to figure out f of 2? Go to the graph. This is the graph of f. Thank you for labeling that this is the graph of f. F of 2 is -4. Check. F prime of 2?
0.
Is 0. Myra, why is f prime of 2 0? Because this graph of f has a horizontal tangent line, so f prime of 2 must be 0. Well done. So I would look and say, did you correctly get f of 2 and f prime of 2? That would be worth 1 point. Did you simplify to get to -16? Probably a 4-point question. How many of you guys would have earned all 4 points? Nice. All right, I'm going to pick somebody else for 1B. In like a moment.
Do you have to like write out plugging it in, or can you just like say g prime of 2?
Personally, I would be hard pressed to go from g prime of 2 to -16 without doing some of this work in between. I at least have to know what f of 2 and f prime of 2 are. Right, those are things I'm gonna have to do a little bit of work. So I'd probably write this part out. I'm not saying that you have
Oh, F
to,
prime of 4, I don't know.
but I would need to write it out.
Okay, if you don't know, nobody knows.
Oh wait, you gotta just use the equation to find it. Or
Well, I mean,
to, not, I guess predicts.
well, you know that F prime,
All you have to know is that all you have to know is that it's positive. So it's gonna be increasing. All you have to know that it's positive.
Watch this, I can find it.
So
All right, one more minute and some random lucky teenager has their work for 1B put up there.
this is positive, so that means it's increasing at X.
ILA, since you went first, you can drive the name selector.
2. Oh, yeah. Oh, well, you don't know, but it's increasing.
All you
Oh,
have
you
to
don't
know.
need it. Final four is gonna be F of 4 is gonna be 0.
All you know is the answer is positive.
It's increasing.
I'm sorry, what was that you just said,
H of X.
Celeste?
So it was
Because you just need to know if it's positive.
yeah.
Celeste, I thought I heard you use the word it.
That wasn't.
No, she was like, oh.
All right, randomly selected teenager, how you feeling about this? You ready? Nothing bad can happen. All right, here we go, 1B. All right, let's look at where we got here. All right, h of x equals f of x over x squared. Determine whether the function h is increasing or decreasing at h equals 4. So clearly, we have to find a derivative. H of x equals f of x over x squared. Quotient rule. Low d high minus high d low, low, low. How are we feeling about her derivative here? Giselle, I was a little confused at first in my old man brain because when I think quotient rule, I think low d high, and you wrote d high low. Is that okay?
Yes.
It's multiplication, the fancy property that allows you to do that. There's a property, begins with a C, ends in a mutative. You guys even with that, you're like, I don't know. It's the commutative property from multiplication that says multiplication in any order gets you the same answer. There's one more place where you have the commutative property. There's one other operation where the commutative property applies. Addition. 3 plus 5, 5 plus 3, same thing. How about subtraction?
No.
Nope. Division?
Nope.
Nope. Commutative property is special for addition and multiplication. All right, so this derivative, I'd say 2 points. Now we need h prime of 4. F prime of 4 times 4 squared minus 2 times 4 times f of 4 over 4 squared squared. And this is where people started to panic, I think. F of 4, everybody knew was 0, but what about f prime of 4? F prime of 4, what the heck is f prime of 4? Oh, I don't know what f prime of 4 is, but I do know.
You do know that f prime of 4 is positive.
I do know that f prime of 4 is positive because the graph of f is increasing at x equals 4. So positive times 16 minus 0 over 4 squared squared.
Positive.
Positive, that's all I care about. Okay, there is something that I don't love in her work here. One small thing that I don't love, that I really want to love, and I can't love it as much as I want to love it. Myra, what can I love here?
Just that it's increasing, but we don't know what's increasing.
I don't know what is increasing, that's part of the problem.
Or where.
Or where. So, Aaron, what's the conclusion here?
H of x, the function h of x is increasing at x equals 4.
H of x is increasing at x equals 4 because
H prime
of 4 is positive. This I love. Giselle, you would get the full 2 points for the derivative, the full point over here for the number. I would absolutely withhold the point over here. Tell me what is increasing or decreasing. Tell me where increasing or decreasing. Tell me why increasing or decreasing. All the friends are good? Number 3, go for it. Some other randomly selected teenager will have their work. Don't throw my cup at her. Pick that up, please. Well, then it fell in a very aggressive way. Okay. Problem number 3.
Let's get these in.
Good girl.
Product proportional. No. And then the log so that we know forever. Mr. Lang and I will thank you greatly for your posters. Whoa. You're right there, Grace. Voice a little bit flat. And it changes all the time, right? Yeah. So g of x is cosine of j. So you're trying to find the derivative of j prime? Derivative of j, sorry. So this would be?
Oh, wait. Never mind. I just realized.
Right, dx over x.
Yeah, but that, what did you have to do?
Wait.
Okay, you plugged in codes for both vectors. Okay.
No. No.
Alright, if I can interrupt all the good conversations that are happening just for a second. So I've seen in somebody's paper that j prime is x times e to the x minus e to the x times 1 over x squared. How are we feeling about that? Like, we're done?
No. Simplify.
Why are we not done? Aaron, why are we not done? You could simplify that, but that's actually not why we're not done.
Oh, it's also not what we're looking for.
This is actually not what we're looking for. What I'm looking for is h prime. H is equal to j of g of x. So if h is j of g of x, then h prime is j prime with g of x plugged in times g prime? Okay, I'm curious, how many of you all actually, when you said, let me find j of g of x, and said j then is e to the cosine of x over cosine of x? Like you plugged in the cosine of x first and then took the derivative? Carmen did that, Andrew did that, David, you did that. Could we get to the right answer using these two pieces of information?
Yes.
Right? Chain rule says h prime is j prime of g times g prime. We know what j prime is. All that I need is I need to know what's j prime if I plug in g. So rather than x times e to the x, plug in g. Cosine of x times e to the cosine of x minus e to the cosine of x all over cosine of x squared. That's it, we're done? Life is good?
No.
No.
Why not? Why are we not done? There's a really good reason why we're not done. Ailey, why are we not done?
You can multiply it by derivative of g of x.
Right, if I'm gonna go with the chain rule, which is find j prime and then like put in the baby, times the derivative of g, and the derivative of g should be negative sine of x. That would be a great answer. I don't know that I could make that answer any better than what it already is. I would leave it just the way it is.
Or you can leave it like that?
Unless the instructions are telling you have to simplify, like Stephen, on your homework assignments, now you are like pushing the boundaries on simplifying. You're simplifying in ways I don't think most human beings can simplify. That's great, but you can also stop. You can stop here, and God, if only you would stop, life would be good. All right, so with the last 3 minutes, I want you guys to see what you can do with problem number 5. Aaron, this is what I'm going to pull you out. You're going to come over to the side here, and you're going to earn your power rule sticker, or I'm going to shave your head. It's one of the two.
All right, time to go. Wait, my name is going over there.
Did I say, oh, I said Aaron, I meant Andrew. You already have your power rule sticker. I meant Andrew.
Oh, not one.
All right, Andrew, everybody else is working on some physics. Sorry, Aaron, didn't mean to threaten you. Okay.
This is a integral.
Wait for our top.
This is an integral.
Oh, yeah, yeah. Back in there.
Find
You have to find
acceleration first time.
It's prime velocity, right?
Number 5.
Double prime the acceleration.
Velocity when the acceleration is first equal to 0.
That's what you have to do.
You have to find the derivative.
I want the velocity the first time the acceleration is equal to 0.
No. Yes.
What could we do?
Cosine of
Take a derivative. And then another derivative, right? Because you're starting with position.
Basically,
You take one derivative that gets you to velocity. Another one gets you to acceleration. Good, keep going.
Yes. Negative sign.
Because what you're finding, you found the derivative, which is velocity, and you found the derivative correctly. But now you're telling me the velocity at 0,
Yeah.
and that's not what this question's asking.
Oh wait, this is the.
No, it's not gonna change.
Right, you're starting with position. I want to know what's the velocity when the acceleration's equal to 0.
Yeah, you're
All right, friends. So this weekend, 2 things. Number 1, take-home quiz, 30 minutes. Number 2, spend some time with the inverse functions. Andrew, you can just leave that on my desk. I'll get that taken care of. If you don't spend the time this weekend looking at inverse functions, Monday is going to be bad. really epically bad. Don't let that happen. See you later.